Okay, so just looking at the first example, for each of the following state the domain and range and whether the relation is a function or not. So first up, state the domain. So for A, we've got the points 1, 4, 2, 0, 2, 3, 5, minus 1. So the domain is all the x values. So that's going to be, we've got 1, 2, and 5. And the range will be 0, or minus 1, 0, 3, and 4. Okay, because we've got points, they're going to have points in there. Okay, is these points a function? Well, it actually turns out that it's not, because we've got two x values the same, and we get two different points for y. So if I drew that on a graph, just roughly, so 1, 4 is up here, 2, 0 is over here somewhere, 2, 3 is this point here, and 5 minus 1 is over here. When I try the vertical line test, this one works out, but here it touches it twice, which automatically says not a function. Okay, so you just need one case where the vertical line test fails and it's not a function. For part B, we have, looks like a quadratic. So it looks something like this. Got some points in there. So if you've already got a graph, it's really quick and easy to use the vertical line test. So just draw some vertical lines. Does the vertical lines touch it only once in every case? Yes. So yes, it only touches it once in every spot. So B is a function. For C, we've got a circle. So having a look at the circle, well, we should be able to see that it's not going to pass the vertical line test because this line here crosses the graph twice. Okay, once here, once here. Also here. Okay, so again, only has to happen once and we can say it's not a function. However, we do touch it once on the very edges. So on the edges, it would be a function, but because it's inside, it's not going to be a function. So it's not a function because it fails the vertical line test. Then we have part D, where it says y equals 4 take x cubed. So we've got a cubic. We could draw it in. It's a negative cubic, and it's been moved up 3. Something like that. And we can use our vertical line test. I'll use a different colour. Okay, it's going to touch once in every spot. Okay, so is a function. So we're just going to have a look at types of correspondence. So using our vertical line test, functions and relations can be classified according to the correspondence between the coordinates of their ordered pairs. So first one, we've got a one-to-one correspondence. So that says where each x value is paired to a unique y value. So these are functions. So for a function, it has to be a one-to-one. Okay, using the vertical line test. So we've got a straight line. This is going to be a function because we can use a vertical line test and it touches the graph once. Okay, we can also use the horizontal line test as well. So this is the vertical and we check the horizontal. So does it touch it once every time on the horizontal? Yes, okay, it only touches once, so it's a one-to-one function. A many-to-one, okay, where more than one x value may be paired to the same y value. So, we might have the points 1 and 2, and 2 and 2. Okay, so when we use our vertical line test, touches each time once, but when we use the horizontal line test, it's going to touch it twice. So here's our, so it's almost going backwards, many to one. So our horizontal part determines many or one, okay, one, and vertical is the one on the right. So more than one x value may be paired to the same y value. So you've got two x values, same y value. A one-to-many correspondence, each x value may be paired to more than one y value. So it's easier to draw points for these. So we might have the points 1, 2 and 1, 4. So same x value, different y value. Okay, automatically the vertical line test fails, but we get a one-to-many. Same x value, different y values. And a many-to-many function, so obviously more than one x value may be paired to more than one y value. So we've got 1, 2, 1, 4 and 3, 4. So 3 points. So we've got the same x value, two different y values, same y value, two different x values. So we've got many to many. So there's a bit of a definition on page 262. So a function has one-to-one correspondence if the horizontal line cuts the graph exactly once. Many to one if the horizontal line cuts the graph more than once. A relation which is not a function is a one-to-many correspondence. The horizontal line cuts the graph exactly once. The many-to-many is the horizontal line cuts the graph more than once. So that's looking at functions. A couple more examples. Got a straight line. Okay, as I said, has a one-to-one function, or correspondence, sorry. Okay, each x and y value only has one x and y value associated with it. Quadratic. A many-to-one correspondence because our horizontal line touches it twice in more than one spot, but our vertical line is always going to be 1. So this is a one-to-one. This is a many-to-one. Okay, both are functions still because it passes the vertical line test, even though this one doesn't really pass the horizontal line. We get 2 points. It's still a function. It's just looking at the horizontal line. And I'll just do a quick example of a one-to-many. Okay, a sidewards quadratic, and we get a one point for each horizontal line, but each time we do a vertical line we're going to get 2 points. So we've got a one-to-many function. And a many-to-many function is going to be a circle. So each time we go horizontally we get 2 points.